Hello everyone, welcome back. So in this video, we are going to learn about the 12 factor different methodologies which should be used in the mainly into this IT infrastructure. Like if you are a system admin or a DevOps engineer or cloud engineer or cloud architect, and this should be the mandatory rule which we should know that in the current market. And I have created this content so that everyone should understand it easily. Hope I will meet my expectation. So at the end of the video, please share your comments. Okay. And also just share to your friends, to whoever wants to make a clear understanding on this 12 factor app. And one important note here it is, if you feel I'm slow, please use the settings button and you can increase the speed of the video. And if you find I'm speaking fast in the video, please slow down by changing the settings for the playback speed. Okay, so without any further delay, let's get started. Let's get started with the code base. Using the code base, what we can do it. So when it comes to the enterprise level, to develop a particular application or a product, there will be multiple developers. That is, it's not a one developer, there will be multiple developers. So whatever the code which is being developed by the developers, where we need a common system to save the code, and all the code should not get overwritten. And that is also one of the factor which we have, and the code should not get messed up. So how do we consolidate this, and how do we streamline the code which is being prepared by all these developers? For that, we should use any one control system which is available in the market. That is, one of the version control system is the Git. This is also called as the code base. Code base, in the sense to store all the code which is developed by our developers. So whenever there is a done work by these developers, so that will be saved in a particular repository, and that repository will be used for the further development, or that will be deployed into the production. And coming on to the next, here we have, this is another example which I would like to go through with you. Now, when there is an application, there will be multiple service which will be available. And as we talk about, for each and every services, there will be a Git repository. And now here in this case, for three different services, we are maintaining one code repository. Okay, and that repository is being deployed into the three different environment called as dev, UAT, and the prod. So now this should not be the practice, because when there is a development work which we are having it, let's say when I need to update only in the search service, I need to make some patch update only into the search service. When I'm deploying this, what will happen is all these three will deploy instead of one, and that will be deployed in the respective environment. So even when we have 50 services, rather than deploying one service, we will be deploying all the 50 services into the repo, and that will be deployed into the particular environment. And this is a broad practice. And what we are supposed to do is, for each and every services or for each and every product, we should maintain a separate repository, and that repository will be deployed in the respective environment. So this is the prescribed method by the 12 factor methodology. So finally it says multiple apps sharing the same code base is a 12 factor app violation. So for each and every product or a service, we should maintain a separate repository. Coming on to the second one, dependencies. When we are developing any software or the package, there will be a multiple dependency will be there. So when we are developing any WAR file or the jar file, Java based application, or any web application, where we will be saving it in the Git repository. When we are saving in Git repository, so this development files might in need of some dependency file like pom.xml file, package.json, if it is a Java based code, or we will need a Gradle. So likewise, there will be multiple dependencies files will be there. So what we need to do is that should not be a part of a code, and that should be separated, and that should be deployed into a particular image, that is as a container. So that will be bundled in a container, and that will be deployed in the respective environment. So here the dependencies should get isolated from the application code. That is, in short, this will have the functional logic, and this will have the supporting files. So what the 12-factor app says is explicitly declare and isolate the dependencies. So we are done with the second one. Moving on to the third one, config. So all the configuration, whatever we develop for the particular package, okay, and that will be within the code. Okay, the configuration in the sense the database details, variables, and the Kafka connecting details, or the connection details, are nothing but the configurations. And now this, for an example, this is a Java snippet, that is a code snippet. So here you could able to see I have mentioned here the JDBC URL here, and also the username password which is going to connect. So here the code should not be hard coded as like this, and this is a bad practice. So what we should do is the application code should be separated from the application configuration. So code should be separate, and the configuration files should be separate. So now if you want to mention about the DB details, so you can mention it in a separate environmental file, that is the DB host. This is the whole local host, and DB port number, username, and the password, and the code should be the separate. Now here you can able to see here we are calling the particular variable database username, database password, DB database. So these values will be called here whenever required, and that will be used. So this is the right pattern of using the configurations. So another example here for this configuration is when we have the application code, it should have the three different environmental files. Okay, for development, they will be having the different database details. For UAT, it will be UAT database. So likewise, we have to maintain a separate environmental file, and that should be bundled with the images to deploy it as a container, and that will be deployed into the respective environment. And this is how this microservices should be developed. So the configuration should be separate from the application code. So what it says, store the configuration in the environmental file. So that's what the 12-factor app says. And we are done with the third one. Moving on to the fourth one, that is the banking services. In the banking services, see, when we develop a particular application, the application for sure it will be have multiple attached services. See, a Kafka will be the MQ message broker service, and we will be having the database to store all our data, and there will be a Redis for the DB cache management. So likewise, we for each and every app, we will be having multiple attached services like this. Even we will have SSO authentication or OAuth, something like that. So now let's say if this database goes down, just by changing the URL, this is the webzone.db.2.com, we should be able to provision or connect to the another database. That's how this attached resources should be designed or the architected for the particular application. That is, in short, to say this should be in a plug and play mode. That's how it should be architected, so that the application will not have the much weightage. That is, all these attached resources should be loosely coupled. And what the 12-factor app says is treating backing services as attached resource. So all these backing services should be the attached in the detached mode. Now, coming on to the fifth one, that is the build, release, run. This is an important one out of all the 12. The reason is when we are developing an application, here we will be having the build, release, run. So all these three stages should be separated as a three different stages and should not be the one. So build stage should be the separate, release should be the separate, and run should be the separate one. And what we normally do in the build stage, the code which we are having in the Git repository, that will be bundled with the image which we are using, and that will be ready for the deployment. And the release, we will be maintaining the different branches, because if release 1.1, if it is deployed and if it is having some issues, then if you want to revert back to the previous version, then we can able to revert back. For such reason, here we will be having the different version formats. Okay, and finally it will be the run, that is to deploy it. So we will be deploying in a respective region. So the reason behind for differentiating these as a stages, whenever there is a bug, we can able to easily mitigate the issue or the error when it is occurs. We can able to sort it out to in which stage it occurs. Accordingly, we can able to find it and we can resolve the issue. And in turn, this is the recommended one. And in the enterprise level, this build and release stage is considered as the CI part, and this run, that is the deployment, is considered as the CD part. See, in the market for the CI, we are having multiple tools which is available in the market, like Jenkins, Bamboo, Travis, and all the cloud provider also, they are having the respective tools. And for the CD, for the deployment, we will be using Terraform or Ansible or whatever it is which is available in the market. So this is what all about the separating the build, release, run. And it should be strictly separate the build, release, run and the run stages. So this is what the 12-factor app says. And coming on to the sixth one, the processes. This processes, here we will be having multiple processes when we are making our product into the operational. Let's say when an end user is accessing our URL, our application through the load balancer URL, for sure the load balancer in turn will connect to the multiple microservices, because the request might be served in MS1 or 2 or 3. When the user is requesting, all the user info will be saved in a microservices, right? It can be a session info or it can be a user info, something like that. Okay, so now what happens if the session info is, if it is saved in the within the microservices? Let's say if it is saved in the microservices too, and what will happen if this microservices too goes down? What will happen? What will happen if this goes down? So for that reason, we should store all the data into the database or the Redis and not into the microservices, because these are not volatile in memory. Okay, and if we are saving within this microservices, okay, and that is called as a sticky session. So we don't maintain any sticky session in the load balancing part. So all the data should not be saved in any of the containers or the microservices, and that should be saved into the separate database or the Redis. So execute the app as one or more stateless process. Okay, so that's what the 12-factor app says. Stateless process in the sense, so we should not save any data into the processes. Okay, coming on to the seventh one, that is the put binding. What in the put binding which performs? Now see, in the traditional method, we used to export the service, either if it is a jar file or a war file, once it is developed by the developer. As a engineer, a production support engineer or application support engineer, we used to deploy it in a one server and another server and another server. And then we will be restarting the Apache Tomcat service in each and every boxes, and the 8080 port number will be enabled in the each service. So that's was the traditional method which we have used. When we are having a particular developed files, we will be deploying in each and every server, and then we will be restarting the service. But using the port binding, what we are doing is, for creating, while creating the microservice, the war file will be bundled with a particular image. Okay, and that image will be deployed as many as times in a single server. And when it is being deployed as many as times, so that will be running as a containers. So here we have 4 containers which will be exposed with the port number 8080. How would this is exposed? Every Docker file, every Docker file will have a command called as a expose but the particular port number. Using that, it is the particular application is getting exposed. So here in the traditional method where we are deploying in a each and every server, but here we are creating as a container and exposing the service in the port number by using the parameters in the Docker file. So export services via the port binding. That's what the 12-factor app says. And the next one here, the eighth one, concurrency. What does it mean by concurrency? It's when multiple processes runs at the same time, it's called as the concurrency. So in the vertical scaling, see the vertical scaling happens when we are increasing the capacity within a single server. Okay, within a single server, when we are increasing the capacity, that is called as a vertical scaling. Let's say in one machine, you're having 1 GB of hard disk and 1 TB of a RAM. Okay, when you want to just upgrade that RAM and the hard disk to the 2 GB and 2 TB, okay, as there is a load is getting increased, that is called as a vertical scaling. But this is not a prominent way for the large and for the enterprise level, because they can keep adding the capacity once the load is increasing. But what they will do when the load is getting decreased, they cannot remove it and they cannot plug in again. So that will become as a cumbersome work. So what we need to do is we need to avoid the vertical scaling, and we need to encourage or implement only the horizontal scaling. The horizontal scaling, it will be like a creating another pod or adding just one more instances. So when the load is getting increased, let's say if the one instance is having 1 GB and 1 TB of a memory and the hard disk, and then I can add one more. Okay, on the total, it will be considered as a 2 GB and 2 TB of a RAM and the hard disk. So likewise, whatever the quantity I need, I can add one by one. So even if when there is a load is decreased, I can just remove it. Okay, so I will not disturb any other instances. So that is the advantage in the horizontal scaling. If you want to have a more detail in the vertical and horizontal scaling, I have just given the link at the description. You can also check out that if you need. Okay, so that's why it is recommended to use the horizontal scaling in the environment. So what the 12-factor apps is scale out via process model. So by this process, we need to increase our capacity. Okay, coming on to the ninth one, disposability. So disposability is, see, whenever we does not require, we should be disposed fast. So that is deploy the application fast. Deploy the application fast in the sense, see, the moment once you deploy the application, it should come in the microseconds. You should not wait for 5 or 10 minutes, something like that. Okay, the database connections, Kafka connection, everything should be done in the faster fashion. That's how you should make your application ready. And also the restart. See, the restart in the sense, if we want to shut down some application and we should able to bring up something means, so the shutdown also should be done immediately. If shutdown is taking 1 hour and if a startup is taking another 1 hour, so it means that for the 2 hours the application will be down, where the client or the end user will not accept that. So we need to make the immediate shutdown or the graceful shutdown, and it should be come up immediately. And also the auto scaling option, that is whenever the more capacity is required in the horizontal scaling, we can add the instances and we can manage the incoming load. So what the 12-factor app says is maximize your robustness with fast startup and the graceful shutdown. That is, it should start it immediately, and graceful shutdown means, so whatever the transaction which is being processed, that transaction should be get completed and then it should shut down the particular service. Okay, coming on to the 10th one, that is the dev prod parity. See, dev prod parity, it says, so when we are having a development environment, there will be a database. Let's say they are using Oracle database 11.2 and the UAT database and in the UAT the database version is 12.3 and in production also is 12.3, but you can able to see that there is a version in non-syncs between the development and the UAT. So this should not be the case, because developer will say my code is working in development environment and it is not working in UAT, so I don't care about it. So to avoid these kind of issues, we should have a same kind of version across all the environments. Okay, so now this is what is recommended. So whatever the tools which we are using, it should be the same across all the environment. Okay, so if it is the same versions across all the environments, using the 12-factor app, we can able to make the deployment within hours. Because even if the code is being deployed in the morning, we can able to deploy it in the night. But in the traditional app, they will be checking each and every tool. So if it is deferred, they will be changing the versions, functionalities according to that, and that will take a week time. And in 12 factors app, the same code owners will be deploying the code. Okay, they will develop and they will deploy it. But in the traditional app method, that is in the previous days, where there will be a separate team to deploy the code, that is change management or production support, or the application support team will do this. So that's the effectiveness of the 12-factor app. And what it says finally, keep the development staging production environments as similar as possible. Okay, so that the production may go smooth and faster. And the 11th one is the logs. See, the logs management is one of an important one which we need to manage it. So when we have multiple containers or the multiple microservices, their logs should not be stored within that container. It should be stored in a separate storage device. Okay, so that we can consolidate all the logs and we can store it in a Elasticsearch, and then it will be processed by the another process called as a Logstash. And finally, we can able to visualize using the Kibana. See, this is one of a tool which is available in the market. So first point here is you should not store the logs in your container, because whenever the container restarts, the log information will get flushed off. So store it in a separate storage or environment, and that will be processed by the Elasticsearch, that is with the event stream, and then it will be processed with the required data formats, and then finally it will be visualized using the Kibana. That's how this log management should be carried out. What 12-factor app says, treat the logs as a event stream. Okay, so that is, it should be consolidated and it should be as a one transaction for each and everything. And the final one, here we go with the admin. Okay, what is this admin process? See, when we are having a particular application, for sure, it will be in the backend, it will be having multiple services. Okay, if when there is a problem or when we want to just to do some maintenance job for each and every services, we should not log in into the service directly and check something or to take a report from some of the services. What we should do is we should run a separate admin process to collect all the info whatever required for this application, and that should be given into the API format or any other format for the reporting purpose. Okay, and that's how here we should maintain the applications. Okay, applications will be running, and if you want to do any hospitality work, and that should be run by the separate admin process, so that we will not disturb the actual application process. Okay, that is the which is called as the anti-pattern. Okay, right. So finally it says run the admin and management task as one of a process. Don't include in the main process. Make it as a separate process so that we will not disturb the application process. So this is all about the 12-factor app methodology. So that's it, everyone. So hope everyone understood this 12-factor methodologies. try to compare all these methodologies in your working environment, how it is implemented in your environment. So that is for all the 12 factors. And if not implemented, try to speak with your senior management, or to your colleagues, and try to implement this 12 factors so that you can able to work, or you can able to build a strong, stable, and a resilient environment for the next 5 years down the line. Okay, and also share this video to your friends to sounds technically better. Thank you. Bye bye.